Okay, so on this one we have to start with distributing 2.4 times the 3.5x, which is going to give us 8.4x. 2.4 times a negative 1.5, negative 3.6, and of course that equals 4.1. Now what? We'll add 3.6 to both sides. So 8.4x equals 7.7. What's next? We divide by 8.4. So we divide that out. X equals 0.916667. Any questions? Now when we're combining fractions like this, now I did this a different way, but if you have a fraction like this that we're going to divide out to make a decimal, 7.7 over 8.4. Obviously we're going to move the decimal point so we're not dividing by a decimal. So both of them are going to get multiplied by 10 to make 77 over 84. But before I go and set that up to divide as a decimal, I would reduce that fraction. Both of those numbers in there are divisible by 7, which would make that 11 over 12. To me, it'd be a lot easier to divide 11 divided by 12 than it would be 77 divided by 84. So some little things that you can do to help you with those calculations if you're trying to do them by hand. By no means am I going to force you to do them by hand. Okay, so our next step, we're going to start looking at something I think is one of the most powerful tools in math. We've peeked at them a little bit before. Now we're going to look at them in detail. Percents. To understand percents and how they work, you first have to understand the word percent. It's actually two words. Per, you think of like miles per gallon or dollars per hour, it's for each or out of. And cent. If you think of cents in a dollar or years in a century, that's 100. So percent literally means out of 100. So if I say 34%, that literally means 34 out of 100 as a ratio. In fact, it's that easy to turn a percent into a fraction. It's just like that. It's always over 100. Now, we wouldn't leave it as 34 over 100 because both of those can be divided by 2. So we would reduce it to 17 out of 50, or 17/50ths. So if we have 60%, how are we going to make it into a fraction? Where is it going to start? 60 over 100, yep. And both of those can be divided by 10. Give us 6 over 10. And still divided by 2. Give us 3/5. You might have 48%, which is going to become 48 over 100. Both of those can divide by, or they're both even, let's divide them by 2. 48 divided by 2 is 24. 100 divided by 2 is 50. Are we done? No, they can both still divide by 2. 24 divided by 2 is 12. 50 divided by 2 is 25. So 48% is 12/25. How about something like 135%? That is still 135 over 100. A lot of people want to put an extra 0 in there and make it 135 over 1,000. Don't do that. It's always over 100. Percents always start out as over 100. Now we'll see that this is an improper fraction. And what I would do is in this form, because it's really easy to take out 100s, I would make this into a mixed number. I can take 100 out of there once with 35 hundredths left over. Now, of course, I can reduce this. Both 35 and 100 can divide by 5. 35 divided by 5 is 7. 100 divided by 5, 20. Am I done? Sort of. What do I still have to remember? 1. Don't forget to put the whole number back with it. So 364%. Talk me through it. 364 over 100. Okay, and then? Okay, so 100 comes out of there 3 times. With how much left over? 64. Both of those divide by 2. Very good. Gives me 32 over 50. Am I done? No, both of those can divide by 2. Give me 16 25ths. Am I done? Sort of. Bring the 3 over there. Oh, you carry it with you as you go? Yeah. That's probably the safest way to do it. $37.5%. Well, it's going to be 37.5 over 100. It's always over 100, no matter what. But we don't like having decimals within our fractions. So just like we did when we were dividing decimals, to get rid of it, I'm going to multiply by 10, because there's one decimal place. Multiplying by 10 will get rid of it. So this is now 375 over 10,000. Now both of those numbers can be divided by careful.
Wait, 100 times 10 is...
Oops. I got an extra 0. No extra charge for the extra 0. Sorry. Is that better? Yeah. Should be just 1,000. You're right. They can both be divided. They'll end in a 5 and a 0, so they can both be divided by 5. So that'd be 75 over 2,000. How about over 200? Apparently I got to run on extra zeros today. They can both still be divided by 5. This is 15 over 40. They can still be divided by 5. 3/8. You could have, if you'd seen it, divided by 125 right from the start. How about 36 2/3%? Well, that is 36 2/3 over 100. Now we don't like having fractions inside our fractions any worse than we like having decimals inside our fractions. So we've got to do something here. We have 2 options. One, we can do like we did with our equations, find a common denominator, multiply it out, get rid of it. Or 2, we can just divide. Let's do the multiplying out. What's our common denominator here? Well, we only have one denominator. It's 3. So if I multiply by 3 on top and bottom, 100 times 3 is 300. 36 2/3 times 3. Well, 36 2/3 has to be made into an improper fraction. 36 times 3 is 108, plus 2 is 110 thirds, times 3 over 1. You'll see that the 3's cross cancel, we get 110 over 1. Or just 110. So now I have 110 over 300. Both can be divided by 10 to give me 11 over 30. Which that isn't terrible to do. The other option would be just to divide that out. 36 2/3 over 100 is 36 2/3 divided by 100. We have to do the 36 2/3 into an improper fraction. 36 2/3 again is going to become 110 thirds. Instead of dividing by 100 over 1, we're going to multiply by 1 over 100. You can cross cancel the 110 and the 100, both divided by 10. Give me 11 and 10. 11 times 1 is 11. 3 times 10 is 30. Either way, we get 11 30ths. What do you think? I want you guys to try 3 of these. (620%), 18 1/3%, 56.25%. Convert each of those into fractions and lowest term. So each of these will go over 100. 620% becomes 620 over 100. First thing I would do is make it a mixed number. 100 goes into 600 6 times. There's 20 left over. Both 20 and 100 can be divided by 20. That's 1/5, and we bring over the 6. 6 and 1/5. How many had that one? Good deal. Down here, 18 1/3 over 100, I'm going to multiply by 3. 100 times 3 is 300. 18 1/3 times 3 is 55. Both of those can be divided by 5. 11/60. Now down here, 56.25% becomes 56.25 over 100. To get rid of the decimal, what do we have to multiply by? 100, because there's 2 decimal places here. So that's 5,625 over 10,000. And the reducing can begin. 25 will work. So if we divide 5625 by 25, I get 225, right? 10,000 by 25, I get 400. They can still be divided by 25. Good. 225 divided by 5 is 9. 400 divided by 5, or 25, is 16. So 9/16 you get. How many got those last two? The 11/60ths and 9/16ths?
I was almost over 11.
Okay. Going to a decimal is just as easy. We said 34% is 34 out of 100. Rather than reducing that, we could go straight into a decimal. That's just going to be 34 divided by 100. When we divide by 100, it just moves the decimal point 2 spots to the left. So that becomes 0.34. Because every percent is just out of 100 or over 100. When we go to convert it to a decimal, all we're doing is dividing by 100 every time. When we divide by 100, it moves that decimal point over 2 spots to the left. So to convert any percent to a decimal, we're just dividing it by 100. 67%, if I divide by 100, moves it over 2 spots, becomes 0.67. 83% becomes what is a decimal? .83, good. 9% becomes what is a decimal? 0.09, good. 230% becomes what is a decimal? 2.3, good. We move it over 2 spots, it's 2.3. 4.8% becomes move it over 2 spots, .048 is a decimal. 0.9% will become 0.009, just 2. 009. So I go over 1, 2 spots right there. 1%, what's that? Always over divided by 100, yep. 1%, 0.01. Now here's the one most people miss. 1/4%. That's what everybody says. But at 0.25, it's still percent. All I did is convert from a fraction percent to a decimal percent. Still have to divide by 100 and move it over 2 spots. 0.0025. Think of it this way. 1% is 0.01. 1/4% has to be smaller than that. So it has to be smaller than 0.01. It can't be 0.25. This is what we call benchmarks. And we talk about percents more next week. We'll talk a lot about benchmarks and how they fit into things. Well, now let's talk about going the other way. If I have numbers that are already as a decimal, like 0.72, and I want to convert it into a percent, well, we need to know that 0.72 is out of 1. A number or a decimal number is always out of 1 for every 1. But a percent is always out of 100 per 100. So looking at this as fractions, I have to convert the 1 into 100 by multiplying by 100. I have to do the same to my numerator. Multiply by 100. 0.72 times 100 is 72. That becomes 72 out of 100, or 72%. So you can see here, every time we go to convert a decimal back into a percent, we're going to multiply by 100. When we multiply by 100, it moves the decimal point 2 spots to the right. So we're just reversing what we just did. So 0.84 is going to become what as a percent? 84%. 0.19 will become 19%. 0.6, 60%. Just got to go 2 spots. So you multiply by 100, it goes 1, 2, you got to add the 0, make it 60. 2.4. Perfect, 240%. 0.083. Yeah, 8.3%. Perfect. Okay, so now if we want to go from a fraction back into a percent, well, let's start like we did before with one that everybody knows. 3/4 is going to become what percent? 75%. Yep, just 75%. If we didn't know that, there's a couple ways we could have approached it. We could have divided it out. 3 divided by 4 is 0.75, then move the decimal point to make it a percent. Not all numbers are going to divide out easily like that. We also could have done this. 3 over 4. Think of that as 3 out of 4, and a percent is always out of 100. So we could look at 4 times what makes 100? It would be 25. So 3 times 25 makes 75. 75 out of 100, or 75%. So what happens here, what if we don't see that this is 25 we have to multiply by? Let me show you an example of one that's a little trickier. Like 5/8, changing that into a percent. What would I multiply the 8 by to make it 100? Well, what I would do is I would take 100 and I would divide by 8 to figure out what that is. It is 12.5, by the way. But then what am I going to do with that number? I'm going to take 5 times that number. So 5 times the result of 100 divided by 8. So what we've done is they've made a shortcut. Rather than doing 100 divided by 8 and then taking 5 times that number, they'll do 5 times 100 and then divide by 8. If we look at our problem, the 5 and the 100 are diagonal each other. They call it cross multiplying. You multiply the two numbers that are on the diagonal. 5 times 100 is 500. Then divide by the number that's on the other diagonal by itself. Dividing by 8 gives us 62.5. 62.5 out of 100, or 62.5%. If we have 2/7, I want to turn that into a percent. Same thing, I'm going to cross multiply and divide. 2 times 100 is 200. Divided by 7 is 28.571429 out of 100. Or what if I want that rounded to the nearest hundredth of a percent? Tenths, hundredths is right there. I'm going to round it right there. Does it go 5.8 or stay 5.7? Stays 5.7. The next number is a 1, so it stays 5.7. What do you think?
We were all doing great until you did this.
So you did the percents? Well, we'll do more with percents next class.
Well, no, I think actually I was doing really good until we got to
The fractions?
turning the decimal into it. That's
Okay.
like,
This one?
yeah, I don't.
Well, you can think of it like this. This is 0.84 over 1. Has to go blank over 100. Do the same thing. It's cross, multiply, and divide. 0.84 times 100 is 84. Divided by 1 is 84.
And it's always going to work like that.
Always going to work like that. Yes. There is a quiz due tomorrow, Friday, 11:59 p.m. There's new homework for Tuesday. The room next door is open if you want to use the computer lab to work on homework and stuff. I will be here till 5:20 to answer questions.